Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Today we're going to be looking at topic 3.2, prime factorization. And there is a lot to this particular section. We're going to learn about what prime factorization is and be able to sort of find the prime factorization. We're also going to use that information to help us find the greatest common factor and the least common multiple of two different numbers. So get ready for it. So just a general vocabulary review. When we talk about prime numbers or composite numbers, you won't hear the word composite number a lot. Just know that it is related to a prime number. So what do you think they are? If you had said that a prime number is a number whose only factors are 1 and itself, you'd be correct. For example, 17. The only way you can get 17 with whole numbers. There's a typo in there. The only way you whole numbers you can multiply to get 17. I don't know what I was thinking here. Essentially what I meant to say was the only way to get 17 with whole numbers is to multiply 1 and 17. Whereas a composite number is a number with factors other than 1 in itself. For example, 4. The number 4 has 3 factors. You could get 4 by doing 1 times 4. You can also get 4 by doing 2 times 2. And so those are the big numbers, right? Here, a number, right, factors are 1 in itself. So, essentially what you want to do is you want to take a composite number, like 48, and you want to break it down until you only have prime numbers left. So, in this example, they start by taking 48 and breaking it into 2 times 24. Right? We know that we could start with 2 because it's an even number, and oftentimes that's a great place to start. If it's an even number, maybe start with 2. Okay? Then they continue to split it. 24 is an even number. 2 is now prime. 24 is even, so they split it in half again. 2 is now prime. 12, they split in half again. 2 is now prime. 6, they split in half again. Right? And now, if you'll notice in this line here, those are all prime numbers. So you could write the prime factorization as 2 times 2 times 2 times 2 times 3. Or, this is the best way to write it. There are 4 2's, 2 to the 4th power, times 3. There are also other ways to break up 48. The first time I saw this problem, I broke it up into, I did 4 times 12, and then I broke this into 2 times 2, and I broke this into 2 times 6, and then I broke this into 2 times 3. Right? There are other ways to land in the same spot. So what I'd like you to do is try with 28. So 28 splits into, it's an even number, splits into 2 times 14. 14 is an even number, so that splits into 2 times 7. And I believe those are all prime numbers. So we could rewrite this as 2 to the 2nd power times 7. I guess equal signs there would make that the most correct. There's another way to do it, and that's by making a factor tree. This is typically how I write it, but if the other way makes more sense, I'm totally cool with that, right? We're still going to split 48. This time I'm going to split it into 2 and 24. 2 is prime, so I leave that alone. 24 gets split into 2 and 12. 2 is prime, so I leave that alone. 12 gets split into 2 and 6. 2 is prime, so I split the 6, right? And I continue until I'm only left with prime numbers at the end of my tree, at the end of my limbs, if you will, if we get that tree metaphor. So you'll notice there's 1, 2, 3, 4 2's times a 3. Similar idea. Let's try this one with 40. 2 times 20. 5 times 4. 2 times 2. And so you'll notice, right, 2 to the third power, 1, 2, 3 2s times 5. Which if we work the other direction, 2 to the third power, 2 times 2 is 4 times 2 is 8 times 5. Look at that. That must be the prime factorization. Right, let's try it here. All right. We're going to try this prime factorization of 56. They want you to start with the least or lowest prime factor. I ran out of room, which is why they start with 2 here. So how many 2's are in 56? You can figure it out. It's 28. And 28 can be split up into 2 and 14. Right, and 14 can be split up into 2 and 7. And so the prime factorization here is 2 times 2 times 2 times 7. That is an ugly 2. I apologize. Or 2 cubed times 7. Okay. How do we use prime factorization? You can use prime factorization to find the greatest common factor, or the greatest number that is a factor in 2 or more numbers. So here we go. We're going to highlight those steps 1 and 2, and we're going to look at finding the prime factorization of 12 and 42. So let's factor out 12. 2 times 6, 2 times 3. So 2 times 2 times 3. 42, switch color just so we know. 6 times 7, 2 times 3. 2 times 3 times 7. So you are going to multiply the things they have in common. Notice they both share a 2, they both share a 3. So I'm going to take 2 times 3. The greatest common factor of 12 and 42 is 6. Right? I start with the prime factorization. I start by making my factor trees. I find what they have in common. I multiply it together. Okay? The distributive property. Okay? We're basically here, if I take this and rewrite this up here, we are basically going to be multiplying out and in. Right? So, distributive property, we're going to be doing 6 times 3 and 6 times 4. Right? We know that 6 times 3 is 18 and 6 times 4 is 24. So we know the answer to this 18 plus 24 would be 42. The reason that the distributive property is helpful is because I know that both 18 and 24 have a common factor of 6, because this is the number that was being distributed. Right? I know that 18 and 24 both, if I were to make factor trees here, are both going to end up multiplying something by 6. So, some problems here to use and practice with the distributive property. So, I'll show you one, you can do the other, or you can pause and try them both right now. Okay. Pause and try the next two. See if you can figure out this word problem as well. You'll notice here in B, right, I've split the 7 out. I've distributed that across 7 times 2 and 7 times 9. And that's how I ended up with these numbers. Right. You'll also notice that both 14 and 63, and as it turns out, the answer of 77 all have 7 as a factor. In the word problem, I distributed all of them out, but I didn't add together because I'm looking for this expression, and it turns out that that is B. All right, one last thing here, we can be looking for the least common multiple of two numbers, all right, other than 0. So we know that 0 would always be a multiple. So we're going to start skip counting. You could write these down. Sometimes you can do it in your head. So I'll write them down. 6, 12, maybe you're moving faster than I am, 18, 24, 30, 36, 8, 16, 24, 32. I'm going to stop right there because I notice that they both have 24 in common. So the lowest multiple of both numbers is 24. This should be a review from 5th grade math. Pause the screen and try it here. So the lowest common multiple of 5 and 8 is 40 when I listed the multiples out. And you'll also note in this particular case, 5 times 8 is 40. And so you might be wondering, Mr. Heckman, couldn't I just find the lowest common multiple by multiplying the factors together? Like 5 times 8 is 40. Wouldn't that work every time? And you're correct that that would give you a common multiple, but not necessarily the lowest common multiple. For example, if I look at 6 and 8, 6 times 8 is 48. That's a common multiple. The lowest common multiple is actually 24. And so sometimes it's okay to have a common multiple. Sometimes we really want to have the least common multiple. If you had questions about anything today, we looked at a lot, right? We looked at prime factorization. That's a lot of letters. We looked at greatest common factor. We looked at the distributive property. And we looked at least common multiple. If you have questions about any of that, please, please, please come and see me. Otherwise, have a great day, and you're completing 3-2.